Good afternoon, good evening, everyone, as you log on. Welcome to the Upper Midwest Rare Epilepsies Conference. We're going to give a few more seconds here for people to log in and to join us, and then we will get started. Welcome to the Upper Midwest Rare Epilepsies Conference. We're so glad to have you. As we allow others to log in, I want to encourage you to mute yourself as well as to turn off your camera. It will improve your streaming quality. We're so glad to have you with us this evening. We will get started in a few more moments. And good evening to you as you log on to the Upper Midwest Rare Epilepsies Conference. We're so glad to have you with us today. We will get started here in one more minute. We're going to allow a few more people to get started here and to have this really, really exciting opportunity. We're glad you're with us today. We will get started in one more minute. Thank you. Good evening, everyone. My name is Glenn Lloyd, and I am the Executive Director of the Epilepsy Foundation of Minnesota. It is my pleasure to welcome all of you to the Upper Midwest Rare Epilepsies Conference, presented by the Epilepsy Foundations of Greater Chicago, Michigan, Minnesota, and Wisconsin. As you might already know, there are around 3.4 million people diagnosed with epilepsy in the United States, and about 1 in 26 people will develop the disorder in their lifetime, with an increasing number of people being diagnosed with a rare form of epilepsy. Though advances in research and genetics are resulting in an increased understanding of many of these syndromes, there's still much to learn. These rare forms of epilepsy can greatly alter a person's life, and the more we can understand them, the better equipped we are to address the challenges they can present. This conference will focus on research, therapies, day-to-day approaches to living with a rare epilepsy, and planning for the future. Although the pandemic has kept us from being in person for this conference, we are thrilled to share this learning opportunity far and wide using this online platform. Before I introduce our first speaker, I want to thank the Rare Epilepsy Network for helping us plan and promote this conference. The Rare Epilepsy Network, also known as REN, works with urgency to collaboratively improve outcomes of rare epilepsy patients and families by fostering patient-focused research and advocacy. REN includes over 70 rare epilepsy organizations and broad epilepsy stakeholders committed to this common mission. Thank you, REN. Now I'm pleased to introduce our first speaker for the session titled, From Labs to Lives, How Epilepsy Research is Improving and Saving Lives. Dr. Tracy Dixon-Salazar is a neuroscientist, executive director of the LGS Foundation, and a parent of a daughter with Lennox-Gastaut syndrome. She will discuss what led her to become a neuroscientist and review how basic research on the cellular and molecular mechanisms of epilepsy reduces mortality and promotes improved quality of life. Before we get started, Russ Deary, Director of Education at the Epilepsy Foundation of Michigan, will go over some housekeeping for using this Zoom webinar platform. Welcome, Russ.
Thanks, Glenn. So today we'll be using Zoom webinar, which looks a little different from a regular Zoom meeting. As an attendee using a computer or smart device, you'll only be able to listen and view the presentations. We cannot hear or see you. At the bottom of your screen, you'll have the option to chat or use the Q&A feature. Please use the chat feature for any comments you'd like to make or resources you'd like to share that relate to the topic being discussed. And make sure that your chat is set to all attendees and panelists so everyone can see your comments. If you think of any questions during the sessions, please use the Q&A feature, and we'll do our best to answer as many of the questions as possible at the end of each presentation. As an attendee calling in from a telephone, you'll only be able to listen to the presentations. Now I'm happy to hand it over to Dr. Tracy Dixon-Salazar to get us started for our very first session tonight, From Labs to Lives, How Epilepsy Research is Improving and Saving Lives. Welcome, Dr. Dixon-Salazar.
Hi there, thank you so much for having me. I'm gonna share my screen here. Go. Great. Can you see that?
Yep.
Excellent. So thank you guys for having me. I really appreciate being here. It has been a very long road that my family and I have been on with living with a rare epilepsy. My daughter just turned 28 and she started having seizures at the age of 2. And so I always love being able to speak to families about where we've been and where we are now and where we're going. So thank you for having me and for hosting this conference. I hope that this talk brings a sense of joy to your lives in a way that you see the progress that's happened in the last 25 years in epilepsy, from our story, which I'm going to share with you, to where we are now. And of course, it's never fast enough, the progress in research, the progress towards improving and saving lives. But it is moving. And I didn't feel like that for a long time, especially when we first started out in the epilepsy world. So I hope that this talk gives you some hope that things are getting better, and that you know that there are groups out there, like groups within the Rare Epilepsy Network, groups within Epilepsy Foundation, that are there to support you along your journey with a rare epilepsy, something that my family did not have for many, many years in the beginning. So let me just tell you a little bit about my daughter, Savannah. She was born and was typically developing until she was 2 years old. She was not delayed, she was not precocious, she was just perfectly typical. And then out of the blue, at the age of 2, she started having seizures. We had no family history and we didn't know why. And this is hard video to watch. It's a video of Savannah's seizures. So if you want to look away, I'm going to advance the slide. But this was our harsh introduction into the world of epilepsy, having never seen a seizure before and not knowing what epilepsy was, and not having any family history or any idea what we were experiencing. We were woken up in the middle of the night to the sound of Savannah choking and gagging. We actually thought she was choking. We called the paramedics and they arrived. And by the time they got there, what we now know was a generalized tonic-clonic seizure had ended. And the paramedics said, you know, her airway is clear, but what you described sounds just like a seizure. And our reaction to that was, what's a seizure? We had no idea. Over the next 2 months, Savannah went on to have another 4 of these generalized tonic-clonic seizures. We didn't know what they were. We were still calling them spells and episodes because that's what the doctors that we had saw called them. And then she went 6 months without having any. And we thought, phew, we dodged a bullet here. We, you know, whatever it was, the word epilepsy and seizures those words were never brought up. Whatever it was, it's gone now. And unfortunately, we were wrong. At the age of 3, they came back, and they came back with a vengeance. She started having multiple seizure types, like the myoclonic jerk you just saw here. And she started having atypical absence seizures, like you can see here, where she would stare and seize and maybe have some myoclonic episodes in there. At one point, she was having 6 different seizure types, and from the age of 3 until she was much older, the age of 18, she had seizures every day. A good day was 5 to 10 seizures. A bad day was 100 seizures, too many to count. I stopped counting. And our journey was horrific during that 16-year period. What's today, Mom? Back then, 22 years ago, well, 20, unless she's 28, 26 years ago when she was 2, this is really all that we knew about LGS. And she hadn't been diagnosed with LGS at this point, but this is what we knew. We knew that it consisted of multiple seizure types, of a slow spike and wave on the EEG, and cognitive impairment. And we knew that LGS could be caused by a series of issues. We also knew back then that for the causes of LGS, about 70% had an associated structural abnormality as seen on the MRI. And then the other 30%, which is the 30% our daughter fell into, were considered unknown. Back then, we would call them cryptogenic or idiopathic seizure types or epilepsy types. All we knew was that we were living in absolute hell with our daughter. And this is just a glimpse of total seizure numbers that she had across that 16-year period from the time that she was 2 to the time that she was 18 years old. It was the roller coaster that it looks like here. In addition to that, she was at a certain point along the journey starting to require more and more rescue medication intervention. We actually remember a time where there were no at-home rescue medicines, and we were regulars in the emergency room for nonstop atypical absence, nonstop non-convulsive status epilepticus. We didn't know it was called that back then, but we were in the hospital all the time getting rescue meds. And then at-home rescue meds became available to us, and she was requiring more and more and more of those. At a certain point, towards the time of her late teens, she was getting rescue meds anywhere to be between 2 to 4 times a month, weekly for the most part, and she really just wasn't doing well. Savannah was actually not diagnosed with LGS until she was 5 years old, where those features showed up. And we now know, we didn't know this back then, that the LGS is something that evolves over time. It's not something that she was born with. It's something that appears after seizures have been going on for so long while a child is still developing and they remain uncontrolled. I like to sometimes bring up, it helps me to remember what it was like back too, but I'd like to bring up this testimony that I gave back in 2012 when Savannah was about 16, 17 years old. And it was to the Institute of Medicine. They were going to be writing a report on epilepsy across the spectrum. It was a really big deal in the epilepsy field. We'd never had anything like this before. But this was really a snapshot of what our lives were like. And I was charged in 2 minutes to explain to the panel who were writing this report of doctors and patient advocates and researchers and government officials what it was like living with epilepsy. So I'd like to just share those 2 minutes with you now. And I think many of you are living this as we speak, so it won't be any surprise to you. So this is what life was like living with epilepsy for the past 15 to 17 years, since she had started. Medical, she had had more than 27,000 seizures at that point. It had taken her 3 years to get a diagnosis. Initially, they didn't want to label with the words seizure and epilepsy because they were afraid they were going to follow this typical child for the rest of her life and stigmatize her. So it took us 3 years to get the epilepsy diagnosis. And it's the same time that we got the LGS diagnosis. But that was despite having seen 7 neurologists, including neurologists who specialized in epilepsy. We had tried and failed 26 different treatments, including medications, diets, devices, and alternative therapies. And despite our best efforts, we still did not know the cause of Savannah's seizures. Financial. At that time, her monthly drug regimen was costing about $1,600 a month. She had received Diastat, which was the only drug available on the market back then, 7 times in that month so far, and at each syringe was $183. She had been hospital 11 times across this time period, and the last stay that she had cost $53,475. For our lives. In that year, she had been absent from school 41 out of 121 days. It was very uncommon for her to make it to school on a regular basis. For all 12 years that she had been in school, she had had an IEP. The number of years that we as her parents had to fiercely advocate for her to have an IEP, 12. And the number of minutes in a day that we could leave her alone, 0. And then there were the issues that we faced with family that were a lot harder to quantify. How many times I had been late for work that week, 2. How many times my husband and I had been on the brink of the divorce just since all of this craziness with epilepsy had started, at least 3. The number of times that I personally had been clinically depressed, at least 5. And other factors such as the number of times something got canceled in our lives. And I'm not even talking about vacations. We didn't take those. I'm talking about trips to the grocery store, trips to the doctor, trips anywhere were frequently canceled. And then the number of times that Savannah nearly passed away as a result of her seizures, or aspiration pneumonia as a result of her seizures, or injury or other infections. What I needed to know in the beginning when we first started on our journey was, why didn't we get the epilepsy diagnosis faster? It didn't make any sense that doctors didn't want to call it epilepsy back then when that's clearly what she had. I think censoring actually wasted time. Why didn't we know that 1 in 3 people back then had intractable epilepsy? All the messaging early on was that Savannah could go on to live a normal life and we just needed to get control of her seizures. And yet that was not the reality that was playing out in front of us. How come we never knew in the beginning that there were different types of seizures? I have hours of video footage trying to capture a big seizure of Savannah having a seizure because I didn't know that all of these little twitches and stares that she were having were other types. I didn't know that I was going through a grief cycle. My whole family was, and we were grieving the loss of the normal life that we had. And we were grieving the loss of having a healthy child. And so for years, I thought I was going insane because I didn't know any of these things. And the public really didn't understand. One of the worst memories I have is one of my daughter having a seizure on the soccer field, where everybody stopped to stare at her having the seizure. And I picked her up to shield her behind me because I couldn't handle the glares and the mothers grabbing their children to hide them behind them. The public just didn't understand this disorder. And 15 years later, when I gave this testimony, what were the things that I needed to know now? Well, we needed to know the cause. Doctors would often say, don't know the cause of epilepsy, but thankfully we can treat it anyway. And that just was not the case with our epilepsy. We needed help. We had gone into so much debt and second opinions that we were drowning in the costs of our daughter's healthcare. We needed doctors and therapists and teachers that didn't give up on us. There were doctors and therapists who said, I'm sorry, there's nothing more that we can do for your child. And that's the worst feeling in the world because we just can't give up. And so we needed doctors that would stick with us. And we needed help. Epilepsy, as so many of you know, it impacts every aspect of your daily life, the person who has it and the people who are caregivers and are a part of the family. And we needed the world and the people writing this report to understand that we needed help. It's not just what happens during that 1 or 2 minute seizure, but it's everything else that goes along with that. So that's what our journey was like. And even to this day, it still brings tears a little bit to my eyes to think about how painful that was and how frustrating it is that some families are still on that journey today. But there has been progress, and I want to talk about that now. My family has been able to play a little bit of a role in making some of that progress. And so I want to share our story, and then I want to give you some more help about the other research progress that's being made. When Savannah was first diagnosed, I started to read everything I could get my hands on about epilepsy. And it was so helpful to read and learn. There were no online communities. You had to check out internet back then at the library. That's how long ago this was. But I learned that epilepsy was a spectrum disorder. This is something that I didn't know. And there was comfort in knowing that there were other people, even though I never met them, that were dealing with very severe epilepsy, because I had really been led to believe that if we just did our best, if we just kept her on medicine, if we kept trying, that she would obtain controlled seizures, and that was not the case. We learned that epilepsy was really common. Over 3 million Americans have it. And again, many, many people suffer from uncontrolled seizures, with 1 in 26 developing epilepsy and 1 in 10 people having a seizure in their lifetime. I didn't fully understand why we felt so ridiculously alone, but I knew that by reading that there were other people that had this. I knew that we didn't know a lot about the causes of epilepsy back then. In fact, 70% of all people with epilepsy didn't know their cause. We did know some causes, but we didn't know many. And I knew that it was a very expensive disease, and there was often high rates of misdiagnosis and a huge cost burden in family. As I did my reading, I also learned that there were a lot of treatments that were out there for epilepsy, a lot of medications. And yet, despite all of these treatments and the new ones that were coming out, the old ones had been around for a long time, nothing seemed to work in our child. And when I did meet other LGS families and other families with the severe rare epilepsies, it was the same for them. And that held true for things such as ketogenic diet and the other diets, including devices and surgeries, were not always effective. In fact, we were considered super refractory. In addition, I learned that we really hadn't made a ton of progress between 1975 and 2014 in understanding the root causes of epilepsy. And it just seemed to me logically that if we wanted to understand how to treat Savannah's epilepsy, or how to treat any child who has early onset epilepsy and we don't know the cause and they're not responding to treatment, is to figure out what the cause is. And this is really what drove me to college at that time. I wish I could sit here and tell you that I was this amazingly talented high school student. I was very smart and brilliant and just jumped right into college and got a degree. And that's not true. I had not done well in high school, and I spent many years at the junior college remediating and learning. But I wanted to be a part of the group of people who were looking for the causes of epilepsy. And I fell in love with science. And so I was at the junior college for many years. I got my associates, my bachelor's, my master's, and ultimately a PhD in neuroscience. And again, I just wanted to help find the causes. There were so many unanswered questions and so much brain damage that had happened to our daughter because of all of these tens of thousands of seizures that she's had, that I just wanted to help. You know, maybe nothing would ever help her, but we had to make it better for the future. I started in school right about the time of the genomic revolution, right here in 2007, between 2007 and 2010. Started going to school and learning about genetics. And I remember the first time I learned about Gregor Mendel and his genetic pea plant experiments. I thought this is something that could actually explain why a child is healthy one day and then has seizures the next. Maybe there's something genetic. Really fell in love with genetics at that point. And very shortly thereafter, there was an explosion with next generation sequencing, where we went from being sequencing single genes in the laboratory, which is something that I did early on as an undergrad, to being able to sequence many, many genes all at one time. I think many of you now are familiar with whole exome sequencing and whole genome sequencing with gene panels, but that was not the case back in 2010. And so we have come a long way. Here's that same graph showing that there have been so many genes that have been found using exome sequencing and gene panels, especially genes that are associated with the severe epilepsies of childhood, or the DEEs, the developmental and epileptic encephalopathies, of which LGS is one of those. And there are now more than, the latest estimates are more than 500 genes that cause epilepsy that are associated with it in one way, shape, or form. And there's just been an explosion in the number of genes that have been found, which is so important because now we have targets that we can identify to help. So just a little bit more information about genes. There are quite a few single family genes. You know, it used to be back in the days, the early days of science and genetics, that genetic meant inherited. Genetic does not mean inherited anymore. It is not perfectly inherited. Yes, you can have a genetic disease, but doesn't mean you got it from your mom or dad. We know that because mutations can arrive spontaneously in the child after the sperm and egg come together. And so it's very important to know that. But in the beginning, we thought that because there were so many family epilepsies that we had found a lot of genes in epilepsy. And so genetic really became synonymous with inherited. And that's not true anymore. There are a lot of single gene epilepsies, especially ones that cause structural or metabolic disorders. There's well over 500 of these now, where you would see malformations or chromosomal abnormalities. And then, of course, the de novo mutations that really exploded, these mutations that are arising in the child, not necessarily inherited from the parents, can be. De novo mutations can be inherited, but they are not always. And that really led to this just explosion of our ability to find these genes in patients and families. And that has continued for the last decade, 11 years. So whereas we didn't know the cause at about 70% of people with epilepsy, there's actually some new figures that just came out in a paper that just came out in the last couple of weeks, saying that that is now down to 50%. We believe we know the cause in half of people with epilepsy. So that is an improvement, and we're only getting better and better at this as time goes on. I think for those of you that are living in the severe epilepsy space, there are a lot of genes, and there are not only genes. I know that for those of you that maybe have a loved one who has epilepsy, a severe epilepsy due to an acquired form of an injury like hypoxic ischemia, lack of oxygen at birth, or stroke, cancer, infection, it feels like the science is not there for you, but it really is starting to come forward. It's just, excuse me, it's just moving a little faster for the gene epilepsies. There are many genes and they act in all different ways. They act, at the synapse, they act on gene expression. And so we're really going to need to dig into the science, excuse me, dig into the science of each of those as we go. But the reality is, sorry guys, the reality is that there are actually genetic epilepsies where the gene that is identified can influence treatment. So there are drugs that if you have a certain genetic variant that you might want to go on. There are drugs that you might want to go off of. There are drugs that you should avoid. There are things that we should be monitoring for. So this concept of precision therapy or precision medicine, which many of you have heard of, is alive and well today. And science is pushing forward and faster. There's this idea that you would take a group of people. We used to just take people with epilepsy and group them and put them all on the same medicine. But if you can separate them out and say, well, these ones have this gene and these ones have this chromosomal abnormality, or these ones have this acquired epilepsy, and then match them not just to the right pill, but maybe it's a gene therapy, maybe it's an injection, maybe it's a device or a surgery or a diet. And one of my favorite stories is the story of GLUT1 deficiency, where we now know that a large percentage of those young children who have GLUT1 deficiency syndrome can go on the ketogenic diet and have a pretty significant relief in seizures. And that's a huge win, whereas these kids used to just seize forever. So very big deal. So this concept of precision medicine has really exploded with all the new genes and all of the new technology. It is an exciting time to be in science, to be thinking about the possibility of treating the underlying causes for so many of these rare epilepsies. And my family had a small role in that. My work in the lab had a small role in that. And it's only getting better and better. I mean, I don't want to say that it's going to be easy. I don't want to say that the science is non-trivial. I'm just saying that for many, many years, for a decade and a half, I did not have a lot of hope in the epilepsy space. And I do now today, really feeling like we're going to make a difference in the kids that have these severe rare epilepsies. So as I was in the research lab as a postdoctoral fellow, finding genes that caused other people's epilepsy, people would often ask, what about Savannah? How was she doing? And the answer was that she wasn't doing well at all. She was 18 years old. She had been seizing for 16 years. She was having about 300 seizures a month on average, but obviously that fluctuated. Some months it was much higher, and some months it was a little bit lower. She was seizing every day. She was on 7 different medications. She had a vagus nerve stimulator. She was on a special diet. She was getting rescue meds 3 to 4 times a week. She was sleeping about 17 to 18 hours a day, either from medication side effects or from seizure stupor or after seizure states. And she was really struggling to get her words out. She really just didn't have much of a life at all. And so I was talking to my postdoctoral advisor, and he said, we should sequence Savannah in the research lab. I remember this was 11 years ago, so this was not very common back then. It was still very experimental. And so we did. We sequenced Savannah in the lab that I was in, and she was the first what we called sporadic patient who we sequenced, who didn't have a family history of epilepsy. This is before we really knew about de novo mutations. And we sequenced her DNA. We did whole exome sequencing on her. And initially, when my job was to analyze the DNA, so that's what I did for her as well. And initially, when we did the research on her, we found absolutely nothing. There were a few known epilepsy genes at the time. She didn't have mutations in any of those. There were no candidates that looked like they were better than any others. And so we did what I still to this day call crazy mother analysis, something that's just starting to be used now in science. But I took the 300 rare unique variants that all of us are walking around with. Savannah has her rare unique ones, and we all have ours. And I plugged them into an analysis where I grouped them into pathways, into molecular signaling pathways. And like I said, this is something that's happening more now, now that we're starting to, look at the mechanisms of how each of these genes interact with each other. And much to everybody's surprise, especially mine, we did identify a high number of variants in calcium channel genes in Savannah. So she is walking around with a huge number. Like why does she have this many? What was she exposed to in utero to have this many genetic mutations in her DNA? But in calcium signaling pathway. And each of those here are represented on the left-hand slide by red dots, where she had a series of these mutations in different calcium channel subunits. And I think many of you know that calcium channels are very important for neuronal signaling. They release calcium into the cell, which then causes neurotransmitter release, which then fluxes to the other side to the neuron at the other end and creates signaling down there. And that's just one way that calcium channels are incredibly important. And when we took a look at the genes that Savannah had mutations in, she had a really large number in these L-type calcium channel genes, which is a specific type. There are N-type, there are T-type, there are PQ type, but in L-type calcium channel genes. And so we went to her doctor and we showed him the data and said, hey, Savannah's not really doing very well. There's nothing else really left to try unless we start cycling back through drugs that she hasn't tried yet. Why don't we try her on a medicine that acts on L-type calcium channels? And there were medicines on the market at that time that acted on L-type calcium channels. They are used for arrhythmia and for hypertension, so not for epilepsy, but they worked in the right direction. So we had some evidence, two pieces of evidence, scientific evidence and modeling evidence that she had too much calcium going into her cells. And this is really important because if she had too little calcium going in her cells, this would not have worked, but she had too much calcium going through her channels. And so these drugs were blockers. They would close the channels either completely or a little bit, so she would have less going in. And so if she had too little going in, this wouldn't have worked. So we knew that. We thought it was too much calcium going in. And we also knew that whenever Savannah would be given calcium supplements, which a lot of our kids are because of the harsh effects of the anti-seizure medicines, that she would always have horrific, horrible seizures. And this is what really prompted us to go talk to her physician about trying her on this medicine. And to everybody's surprise, this sort of long shot after we did the careful risk benefit and realized that she really had no quality of life and that we were going to lose her. She was getting aspiration pneumonia pretty regularly back then from seizures. We tried her on this medicine and it worked. So within 2 weeks of trying Savannah on this medicine, it's called verapamil. It's an L-type calcium channel blocker. She had a significant reduction in her seizures. Ended up to this day, she is still doing really well. It's a 95% reduction in her seizures. And the drop was really very, very immediate. I think what was even more amazing was the reduction in the use of rescue meds. So the number of times she was going into these nonstop seizures. So Savannah had what we now know were sequential seizures, where they would start out tonic or tonic-clonic, and then they would taper into an atypical absence or a non-convulsive status that would just never end, that could just go on for days and just, rhythmic twitching, kind of like the video I showed you. And that completely stopped. And she had a couple of other sputters and then completely stopped. So we went from giving rescue meds pretty much multiple times a week to not giving them at all. And she is now 28. So this was when she was 18 years old. She is now 28 and she is doing incredibly well still. So I always knock on wood. I feel like I met Savannah for the first time when she was 18 years old, because the reduction of all of the seizures really just brought out who she was. She was awake and she's funny and she's sassy and she's opinionated and bossy. And she went from, 2 to 3 word sentences to I stopped counting after 15 words. We were counting her words, like that was 10 words, that was 11. And we've stopped counting now because she just yells at us all the time. And every year she is getting better and better. And she has things she loves. She loves to dance and she loves to argue with people and she loves to make jokes. And if you had told me that my 18-year-old who had more than 40,000 seizures, at that point, who was so brain damaged from the epilepsy, who had been on a 16-year journey of just hell living with LGS, that drug number 27 was going to be the thing that helped us, I would have laughed at you. I'm serious. I would have been like, oh, that's really cute. But I am never been so happy to be wrong about something, because it was drug number 27, and it was a drug that was targeted towards her biology that made a difference for her. And even though she had so much brain damage from all the years of seizures, she still is learning and growing again. Now, is she ever going to reach the age of a typical 28-year-old? Of course not. She still operates at, anywhere between a 2 and 7-year-old level, but she used to operate at a 2-year-old level. She doesn't read or write, but now she can talk and she can interact and she can walk and she toilets herself and she can dress herself if you've got 2 hours and don't care if everything's on backwards. And so I have a short little video here.
Tickles, tell you can. Tickles. This is Samantha. She doesn't spend her day seizing, unconscious. High five.
So we've really just seen this huge change in Savannah, and it's improved our quality of life as well. I know for the first 4 or 5 years after Savannah started to do better, we still didn't leave the house. We call it LGS jail. It was like we were just so conditioned to not going anywhere and not participating in the world, because there were just so many seizures and it was so hard to navigate the world. And she really is doing so much better and is giving us a run for our money as our own parents. So let me talk about what we know about LGS now. I've talked a little bit about, where we were, and I've talked about Savannah's incredible journey and what we've been through. But what do we know about LGS now? And LGS really is a story of all rare epilepsies, because LGS is a syndrome. It's a collection of symptoms, right? And now we're talking about all of these rare epilepsies as it relates to the cause. And there are more than 300 genes that or more than 150 genes that predispose to LGS, right? Not everybody who has a certain gene mutation and has seizures will get LGS, but there are so many genes, and then there are so many acquired forms, and there's some early research going on in the acquired epilepsies around anti-inflammatories and things like that to really try to target the causes, right? But LGS is a syndrome. So everybody has LGS secondary to something, whether you have LGS secondary to gene mutation A, whether it's TSC or trisomy 21 or SCN2A or CDKL5, or you have it to an acquired injury, right? Like a meningitis or stroke, or, sometimes chemotherapy can lead to seizures, but everybody has LGS secondary to something. This is what we know today. We are a long way from the umbrella slide. We know that in order to get a diagnosis of LGS, you need to have multiple seizure types, and tonic seizures are present in nearly everybody with LGS. And the other most common types are atypical absence and tonic and drop attacks. There's also a high percentage of non-convulsive status, but multiple seizure types you have to have LGS. You have to have an abnormal EEG, and it's not just the slow spike and wave anymore, right? That was originally the only feature. Now it's this presence of generalized paroxysmal fast activity, which seems to be correlated very much with the tonic seizure state in patients. So both of these features. There also is an age of onset. Usually the seizures begin under the age of 7 in order to see LGS, almost all the time, not always. Cognitive impairment is not required for a diagnosis of LGS. That's why it's in blue here. But it is present in more than 95% of patients with LGS within 5 years of the diagnosis of seizures. So it's almost always present. And this is what LGS is. It's a collection of symptoms or a collection of features. But we are finding out so much more about what causes LGS. This is what we used to know, structural versus genetic. But now we really have begun to break out how it was structural. Is it injury? Is it a congenital brain abnormality like a cortical dysplasia? How much of it is genetic? How much of it is infectious, right? What are the genes? And more genes are being identified that predispose to LGS. So what we've started calling it in the LGS world is pre-LGS, right? Your child could go LGS. They have risk factors. They've got multiple seizure types. They've got, maybe their development is delayed. They've got a genetic predisposition, or they had a specific birth injury. They just don't have the slow spiking wave yet. That is a pre-LGS. It could be pre-LGS. And so we really want to advance research on how to stop it. You do not want LGS. Nobody wants LGS. Do not get LGS. But we also know that LGS is a journey. Nobody's born with it. Here was a study where they followed a group of patients that came to the academic medical center, the academic epilepsy center, and they followed them for 15 years. And if you looked, when they first came in, you had the initial diagnosis was undiagnosed, or some had LGS right at the time they came in, some had West, some had generalized, and some had focal epilepsy. Across the 2 years, within that 2-year span, they've all landed on their final diagnosis. And you can see how many went from being one thing to being LGS. So LGS evolves. LGS is something that happens over time while we're watching. And that means we can intervene. We know who's at the greatest risk. When they followed these kids for 15 years, they saw that if the seizures started at less than 1 year, they were at the highest risk of developing LGS, right? And then they started to look, in addition to just the age of onset, but also what was the age of onset. So we know when the risk is higher, sort of predicting your cancer risk, right? Like if you have all these factors, then your risk is higher for developing cancer. And it's very similar here. We can start to begin to think about risk. And we also know that there's the LGS is when the seizures, they're occurring so frequently as the brain is developing that they then take over brain development and they affect the whole network of the brain. And we're beginning to understand what regions in the brain are impacted and what those networks do, where they are, what they mean, how they can be targeted. One of the interesting emerging therapies for LGS and for other disease networks that act on the whole network. I'm not talking about like specific genes early, but like the whole network is now affected. LGS is like the seizures have spread. They've metastasized and taken over the brain. Deep brain stimulation is actually one of the emerging therapies that really acts on that brain network, not just on the seizure, not just on the gene, but on the network for those that can't get early intervention. And most importantly, I think this is even more important, is that we are beginning to track the cases of reversible LGS. You can get rid of the slow spike in wave. And the proof that those patients that do, we don't know how to do this in every case. We can't systematically do it, but you can reverse LGS in rare cases. It happens in adults who maybe have some sort of a surgery like this EEG here. It also happens in young kids who are diagnosed with LGS, get seizure control, and then their brain waves normalize. And so we're going to start thinking about treatments for LGS that actually target the brain waves and not simply the seizures. And as I wrap up here in my last couple of slides, I want to just bring it all home with what we know about LGS now, which is it is an evolution from an earlier journey. So this is what we know about LGS now, right? You've got these clinical features, including childhood onset, and it doesn't really matter where you came from. Once you have it, your odds of having a normal life are the same across. It's diminished. Most have seizures into adulthood. Most have tonic seizures associated with sleep. Most have significant cognitive impairment, and many, many patients die. And we need to treat that, but we need to treat the network, not just the symptom of seizures, because there is so much more to LGS than just seizures. It's GI issues, it's behavior, it's cognitive impairment, it's a movement and ambulation, and it's so many more things than that. And so at the LGS Foundation, we're really looking at treatments that will treat the actual network in LGS. But LGS came from somewhere. It came from treatment-resistant epilepsy. Down here you have time, right? So LGS is most often diagnosed between the ages of 2 and 5 years old, right? And more brain damage ensues the longer you have LGS. But what if we can intervene right here early on? Or what if we can even intervene before? How do we stop infantile spasms? And so we work really closely with the Infantile Spasms Action Network. What are the best treatments for that? We think a lot about preventing treatment-resistant epilepsy, figuring out what are the best medicines in those before they evolve to LGS. And then thinking about what are the best treatments for epilepsy or even for the first seizure in early childhood. because when you have, if brain development is regulated by electricity and seizures are aberrant, just unpredictable electricity, you do not want this abnormal electricity around. And so we've really started to shift our thinking, and the whole field has, to prevention of developing LGS. And then all of these seizures, pre-epilepsy, comes from somewhere. It comes from some cause, whether that cause is a birth injury or a congenital malformation, whether it's a gene, one of the many, many that we've talked about, or whether it's metabolic, infection, immune. All of these are now the subject to some incredible, incredible research on how to stop this evolution to LGS, or even just this evolution to really bad epilepsy, even if your loved one develops something similar to LGS or LGS-like, or even not LGS, just has DEE and it doesn't get the LGS name associated with it. How do we prevent? And I've never been more excited about research than I have in the last 10 years because of this. Is now we are talking about prevention and not just putting a Band-Aid on it. The one other thing and the last thing that I want to say about this, and I hope you're excited about it, but I also want to say is that for the first time ever in our journey, within the last 5 years or so, patients are being listened to in ways that we've never seen before. And so it's a really important time for you, if you're comfortable, to raise your voice about your rare epilepsy. Find your people, find your community of support, wherever that may be. You are always welcome in the LGS community. If you want a community of life hacks for living with a lot of seizures, that's what we do best over here. But find your community, whether it's your rare epilepsy or it's your epilepsy foundation, but it's going to help you through this journey, and talk about it. Raise awareness, get involved in research. And I just want to show you what's really come out of the work that we've done over the last 2 years at the LGS Foundation. Could be summed up in really in one graph about what matters most to families with LGS. And this is being done for a lot of rare epilepsies just beyond LGS. But many of you might remember from psychology class, Maslow's hierarchy of needs. This is this idea that human motivation is set on these tiers, and you have to reach the bottom tiers before you can move up. So your physiological needs have to be met before you can move on to safety needs, right? Like if you don't have food, clothing, and shelter, you're not really thinking about employment, right? And if your safety needs aren't met, if you're not healthy, if you don't have property, you're not going to have love and belongingness or esteem or self-actualization. So this is a famous theory in psychology. And there is after hosting our patient-focused drug development meeting and doing extensive surveys in our population and doing focus groups with LGS families, there is an LGS hierarchy of needs. And it is so far from Maslow's hierarchy of needs that what we're really dealing with is this stressfulness. We have death, we have crisis, and we have just steps to take to avoid crisis. And none of our families are ever independently, our people with LGS are not navigating the world independently. And so we're able to share this with drug makers and with doctors and with scientists. So they're now trying to help us in the LGS field just to deal with the crisis and the non-independence. Like, don't talk to us about school, don't talk to us about behavior, but really talking to us about these areas where we are, to meet patients where they're at. So with that, I'd just like to say thank you so much for joining us, for joining me, and for listening. And if you are navigating the world with a severe epilepsy, I hope you'll find your group of people. I then hope you will get involved in research. And I hope that you feel optimistic about the future as well. Scientists are hard at work trying to make things better. And it really is an unprecedented time in our world for the severe epilepsies. Thank you.
Thank you so much. That was so inspiring and encouraging to see how much great work is being done. So let's get right to some questions. So the first question is, can two children have a single gene mutations? My husband and I do not have any known family with seizures, and we have two kids with different types. In 2 weeks, we hope to get results for my son who has myoclonic seizures.
So I think if I understood the question is, can two kids have the same gene mutation, but neither parent be affected? Is that essentially what you heard?
Yeah,
to the rest? So. Okay, yeah, and the answer is yes. So de novo mutations used to be thought that they are not from mom or dad at all, but there actually can be a very small number of cells in mom or dad that do carry the mutation. And so it's going to be very important to talk to your genetic counselor, right? So you'll want to test mom, dad, and both of the children if you haven't already done that. And then really talk to your genetic counselor about whether the sequencing was deep enough to tell if mom or dad had it. And deep means how many times did they sequence that letter? Did they sequence it 30 times? Did they sequence it 100 times? Like how many times did the machine count that letter? And so you'll really want to talk to a genetic counselor about this. But it is possible. It is very rare, but it is possible.
Okay, great. Another person asked, how come more is not done or more awareness is not made about double cortex syndrome or band heterotopia?
The reason that there is not more awareness is because, and this is probably going to piss off some people, but there needs to be a focused, dedicated advocacy group for that disease. The head of the NIH and the head of the FDA neuroscience program have both said that they would not want to have a disease today that does not have an effective advocacy group that is out there raising awareness and funds for research, for targeted research on their disease for that specific disorder. And we have a lot of families with DCX and with lissencephaly and band heterotopia in our LGS population. A lot of them develop severe seizures, but we need focused research on those specific diseases. And that's going to come from an advocacy effort specifically for those diseases.
Okay, great. And we have multiple people in this conference who have started their own agencies. So that's, it can be done and it has been done. So so that's encouraging to folks who maybe are feeling underrepresented, is that you can start one yourself or find other people who want to start one with you. So have you heard CMV in first trimester equals Lennox-Gastaut syndrome? Not sure what CMV is.
See, there's cytomegalovirus, or I think it's cytomegalovirus. So there is no definitive data on that. I know that there's been research circulating for a long time where they've been actually looking at pregnant mothers and saying, if you get an infection when you're pregnant in your first trimester, your second trimester, your third trimester, are you going to have a child with autism? Are you going to have a child with this disease or that disease? And as far as I know, the jury is still out. I know there's a lot of active work going on in this, right? And as it relates to LGS, that's even harder because LGS is not something, does not come from the gene mutation. LGS comes from uncontrolled seizures, right? So you start with like a gene mutation or an acquired insult, and that leads to seizures, and the seizures become uncontrolled, and then that leads to LGS. So so that's a really hard question. I would talk to your doctor about that. But the research that I've seen, and this is not my field, I'm not on the latest. I just know we used to do this in the lab when I was working, looking at maternal, the immune system in moms and how that might impact the baby. But there's no systematic reason to believe that one virus over another causes this specific type of LGS. We haven't bridged that gap.
Okay. Someone said, my daughter started having seizures at age 8, no developmental delays until around age 10, seizures worsened, and not until her 20s did the doctor use the term LGS. I'm questioning that now hearing this info. I guess, how common is it for people to receive a very delayed diagnosis of LGS?
It is really common. You know, the LGS definition has changed quite a few times over the many years. It's been evolving, right, since it was described. And if you didn't have access to EEG, like we didn't get diagnosis of LGS till Savannah was 5, and we had to drive up to UCLA. We live in California, and that's where they had the EEG monitoring unit. Like they didn't have epilepsy monitoring units back then, right? Like they were just becoming a thing. They didn't have one down here where I live in Southern California. So, you know, I think that, you know, if you didn't have access to the EEG, or if an expert didn't read the EEG, or if you had a doctor who really didn't think that the EEG really mattered because it wasn't going to impact treatment, that information may have been withheld. Not ever for any sort of evil or mean reason, right? I mean, I think doctors are doing the best that they can, but there have been many things where we've learned about our daughter by requesting the medical record that were not shared with us. So I always suggest families get a copy of their medical record and read through it and ask questions.
Okay. So would LGS be diagnosed while typical seizures are under control with medication, but infantile spasms or West syndrome is still being treated?
Well, LGS would be, so there's about 30% of babies who had infantile spasms go on to develop LGS. So there's a very clear link there, but the LGS diagnosis wouldn't be made until the EEG features are present and until all the features are present. So you have to have the 2 EEG features, and then you also have to have the multiple seizure types, and then, the early age of onset. And the seizures are often refractory, and then you get the LGS diagnosis. I have heard doctors say a lot, though, that they look like they're going LGS. So they might have, 2 of the 4 features, but they don't have them all yet. And some kids never go LGS. They just, their EEG looks like it's chaotic. They might develop the slow spike and wave and the PFA, but sometimes they do and sometimes they don't. And that is something we just do not understand and want to understand scientifically.
Okay. Another parent expressing frustration with having been through 6 different doctors, not knowing what's causing the epilepsy and just feeling like it's just, well, let's try another medication and not trying to get to the root cause. Just general advice for parents and caregivers who are frustrated when they're not able to, when doctors aren't able to provide a cause, and I guess what suggestions on managing that frustration and steps you can take to try and get to the bottom of it.
Right. I mean, it is really hard. We're limited by science and medicine right now in some ways, right? So even if you get your LGS kid to the best doctor in the world, right, and you have unlimited funds and you get in early, we don't systematically know how to stop LGS in people, right? Or to reverse it or to prevent it from getting worse. But we do know that what science can do. We do know that if you haven't had genetic testing yet, right? So if the loved one is a child and they've developed epilepsy very young and there was not a birth injury, right? So genetics can't really help with if there was lack of oxygen at birth, or if there was a stroke or in early life, if there was an infection. If those are the causes, then genetic testing won't help you. If those are not the cause and you don't know the cause, whole exome sequencing is really important to be done. And I'm happy to share my email. If you want to contact me, I can give you more information. I'm sure Russ and Glenn can tell you more about whole exome sequencing, as can the Rare Epilepsy Network, how to get that. But you really, if you don't know the cause, then it's really important to get genetic testing, find the cause, because there is a chance that there might be a treatment if it's genetic. Now, most people are not going to have that, because now here's where we're limited with science and medicine. New developments are happening every year. So you don't want to be behind the curve, but you also now find yourself, okay, I know the cause. My child had a stroke at birth. Now what do I do? And now you've entered the game, the waiting game that all of us have, which is where you just try treatment after treatment. And it's so frustrating. And sometimes it seems like there's no rationale to the treatment we're trying. And I have been there. And all I can say to you is, I know that the odds of your loved one responding to the next therapy, whatever that is less than 3%, but it is not 0. The odds of them responding if you do nothing are 0, but the odds of them responding if you do something are not 0. And we know that our children are at higher risk of SUDEP when when they go long periods without, changing their medicines and trying to get their seizures under control. So do what you can to fight. It's exhausting. And if you want to come into the LGS community where we try to help each other through this, it sucks. Like, this is not a good answer. This sucks. But this is where science and medicine are today. And that's why me and the people at the LGS Foundation are just so adamant that the next generation, it has got to be better. We have got to fight for cures and better treatments.
Right. And in your example of, what was it, the 27th?
27. Yeah, it was treatment number 27.
Yeah. So yeah, keep at it. And that I've certainly come across many examples where it's that 10th or 12th or 13th medication that is the one that works. And so even though that oft cited study is discouraging, it can happen. So So thank you so much, Dr. Dixon-Salazar, for an excellent discussion, excellent presentation, and a great way to kick off this conference.